Hello everyone, my name is Andrea Dali, the Bazooka Prophet, and today we'll be working on a very interesting video in the field of chemistry, talking about what we call the grams to grams relationship. The grams to grams relationship, which is under stoichiometry. And we should understand that basically stoichiometry has to do with the quantitative relationship between substances. And under grams to grams relationship, it has to do with basically on the quantitative relationship between the known and the unknown. And for that to occur, one should be able to first of all write good chemical, a good and a balanced chemical equation. And also, one should be able to know the two substances or the two quantity you are relating with each other. And in questions that involve grams to grams relationship, you are always given a known mass and asked to calculate for the unknown what? Unknown mass. Now look at the question on the board. Let me solve it. The question says a general overall equation for the degradation of glucose, which is C6H12O6 to CO2 and H2O. This is the question. This is the question now. If 856 grams of glucose is consumed by a person over a certain period, what is the mass of the CO2? Now, if you look at this question very well, this is the mass of the known substances, one, and we are asked to calculate for the mass of CO2. Very simple. What do? You first of all calculate the molar mass of the two quantities you are relating with each other, and they are, let's come here, the solution. Now, the molar mass of glucose, which is ROM of carbon is 12 times 6 plus hydrogen, which is 1 times 12 plus oxygen, which is 16 times 6. When we do everything, it will have the molar mass to be 180 gram per mole. We move to the molar mass of CO2, which is 12 plus 16 times 2, altogether is 44 gram per mole. Very simple. Now you relate it to each other. Now, how many mole of glucose do I have here? It is 1. So it will be 1 multiplied by the molar mass, which is 1 mole of glucose, multiplied by the molar mass that you have, which is 180, altogether is gram of glucose, would produce or yield 6 multiplied by 44 gram of CO2. Now let's come in. Now, it means that without your balance equation, one would be able to bring out this first statement out. When this first statement is known from your balance equation, then you then move to the unknown mass you were given, which is now 856 gram of glucose will produce what gram of CO2. Simple. What do? Here you cross multiply. When you cross multiply, here now becomes okay, x gram of glucose is equal to, so this times this, which is 856 times 6 times 44 over 1 times 180. And when we do the multiplication, which is 856 and 6 times 44 divided by 1 times 180, the final answer should be 1255.47 gram of CO2. All right. So next is question 2. The question says methanol, which is CH3OH, burns in air according to the equation. This is the equation, which is the combustion reaction. Then I said if 209 grams of methanol are used up in a combustion process. And I said, what is the mass of H2O produced? Very simple. So it means that the two quantities I am relating here is, which is methanol and H2O. So the first I told you, first of all, calculate the molar mass of methanol and also of water. So it will now become the molar mass N of methanol, which is 12 plus, which is 3 times 1 plus 16 plus 1, altogether to give me 32 gram per mole. And that the molar mass of H2O is, which is 1 times 2 plus 16 will give me 18 gram per mole. Then we now relate it from the equation. So 2 mole of methanol, which is the molar mass of methanol, is 32 as in grams now, or mole times gram per mole. The mole cancel mole, left with gram. Of methanol would yield 4 mole of H2O, which is 18 gram of water. The first statement here. Then the second step now is the known quantity, which is methanol, which is 209 gram of methanol, would now yield what gram of H2O. So very simple. So what do? We cross multiply. Here become X gram is equal to, so 209 multiplied by 4 times 18 over 2 multiplied by 32. And when we multiply and we divide, the answer should give me 235 gram of H2O. That is the final answer to this question. Now, in our next video, we will enter the stoichiometry of solution. For now, have a nice day and God bless you.